Hello, everyone, and welcome to today's conversations about carbon. Today, our first speaker of this fall semester is Harry Stein. And Harry is synonymous with many titles: innovator, businessman, entrepreneur. But the title holding the most significance to him is farmer. He was raised on the family property in Dallas County, Iowa, and he graduated from Central Dallas High School and then McPherson College in Kansas. Today, Harry is going to be talking to us a little bit about Stein Seed, and we are happy to have him here.
Yeah, Harry, thanks for joining us today. I was going to add to that, I was trying to describe Harry. It's I don't know if you like this term or not, but you're a bit of a plant breeding mogul. You've made a name for yourself in both corn and soybeans. More importantly, I hear that you're an accomplished morel mushroom hunter. That's a hobby that we both share, although I hear you're much better at it than I am. I don't know how many morels did you find this year, Harry?
I don't remember this year. The last 20 years or so, I think I have 47,000 or a little more.
I think that beats the 8 that I found this year. And if anybody has driven through fields in the Midwest, you've probably run across a number of signs that remind us that Stein has yield. So today, Stein Seed and its affiliates, they employ more than 800 patents. They've got more than 400 people across 16 states, and it's the largest privately owned seed company in the U.S. So nice long list of accomplishments by Harry and that company. So again, I want to welcome you, Harry. Thank you so much for taking the time out of your schedule during what's probably a very busy time of year for you and your team, but we promise to keep this on the clock, which Dana will help me out with. But now, while all your background information is particularly interesting and would be great fodder for a different interview, perhaps today we want to talk about something I've heard you refer to in the past as just a hobby of yours. The series is entitled Conversations About Carbon, and I hope that we can do just that with you today and talk about a form of carbon that I think you must find very interesting, and that would be biochar. So let's just get started with the basics. Biochar seems to be a lot of things to a lot of different people, but from your perspective, what is biochar and why should we care?
Well, it's very important for various reasons, but most plants take carbon dioxide out of the air and incorporate the carbon into the biomass. And when you burn these plants or oxidize them, a lot of that goes back into the air as carbon dioxide. If you do this mostly in the absence of air, if you heat this biomass, you can get a good share of it retained as biochar, which is almost pure carbon. And if we incorporate that into our soils, it pretty much permanently sequesters that carbon.
So you're using it as a carbon sequestration form. What other benefits can it provide to a soil?
Well, to start with, for the last 20 years, we've had our full-time year-round nursery in Guyana, which is a little country in the northwest corner of South America. And the Dutch went there in the 1600s, which is actually, they were farming there in Guyana before we had Europeans farming here in Iowa. And I tell people that aluminum sheeting was hard to come by at that time. So the Dutch made roof tile and for their buildings. And in making a kiln for the roof tile, they threw the charcoal and the unburnt wood and what have you out into a pile, a refuge pile. And the corner of that pile came down into our field. And that soil, and incidentally, where we are in Guyana is pure sand, just like Central Florida is, because that's where the coast was when the glaciers had tied up the ocean. So in the edge of that field, it was black where it was not sand. our corn and soybean plants did 2 or 3 times better than they did elsewhere. So looking in that to a little bit, then we find out there were, quote, petra soils or dark soils when the Spanish first went to South America, and they assumed those were normal, didn't realize that the indigenous people had actually incorporated biochar into those soils to create that. So those soils were way, way better. And so because of that, we had an interest in this, contacted Iowa State University, and have gone from there.
Very good. Yeah, so that's a little bit about the origin story of how you first got into it. I mean, Harry, you could probably do whatever you wanted to do. How did you select to pursue biochar as an interest?
Well, we got acquainted with the Iowa State personnel and tried to do various experiments in creating biochar because we thought that would help some of our soils here in Iowa. Incidentally, we incorporated that into all of our ground that we farm there in Guyana. But here in Iowa, we've got some eroded Clarion hills a little bit. We have some timber soils that are fairly low in organic matter. And we have some bottom land, which is somewhat sandy, not quite as bad as Guyana, but a little bit that way. And so we knew that if we could put biochar on these, this would be helpful. So we've had, over the years, we've had various projects trying to create a system that would do this. So that's where we are today.
Now, when you're talking about soils, I've heard tell that you've done a little bit of experimentation down there by the plant, which primarily the site had served as a clay repository to feed both a clay tile factory and a brick factory. And you took a day and put together your own little test plot using clay soil. Can you tell us a little bit about that? Maybe some future plans you have in that area?
Yes, this is sort of interesting. We actually bought this old brick plant, which is actually where our pyrolysis unit is today. And across the road from that, where they had a mine to mine the clay, there were several acres of just pure clay, the same clay you would use for bricks. And obviously it doesn't grow anything. I leveled a little bit of that off, just a few acres of it, 3 or 4 acres. But in the meantime, I took a little teeny plot and put on a very, very high rate, between 30 and 40 ton of biochar to see what it would do to it, and planted corn and soybeans. And obviously they grew much better in the area that I put it on versus the control area where I hadn't. But it was a very small experiment. We will need to do this on a larger scale as soon as we get biochar to do so.
That's pretty amazing. I can't imagine a worse environment to grow crops in than clay. So you did put in some control, so corn and soybeans next to that biochar plot. What did each plot do? Did you even get anything to happen on the clay control spot?
Well, the corn plants were 2 or 3 times larger on where they had the biochar versus where we didn't. And then the rabbits moved in and took care of the whole thing for us.
Yeah, as a home as a home gardener, I can definitely identify with that problem. Yeah, that's a little bigger scale that you'll deal with there. So from that perspective, we talked a little bit about biochar and what it can do for soils. From the farmer's perspective, what is that value proposition of biochar? Why should farmers be interested in what you're doing and what biochar can do for the soils? And what do you anticipate potential value of biochar could be to farmers and producers?
Well, there's different ideas on how you should do this. We think that you need to incorporate it into the soil, and that requires moldboard plowing. And obviously, most people will not want to do that more than once in a generation, because today that's obviously not good at all for erosion and what have you. So because of that, we think on those soils that need it, that we should put on about 10 tons per acre. And then that will last for a full generation of time, at least. And And because of that, it's going to be $100 or $200 a ton. So that's going to be $1,000 or $2,000 an acre. And people say, oh my goodness, that's crazy. We don't want to spend that much. Well, we think you can take $8,000 or $10,000 ground and turn it into $15,000 ground by only spending a couple $1,000s an acre. And at the same time, when you have these spots in the field that need this, you're going through and putting the same fertilizer and the same seed, the same chemicals, spending the same amount of money on that ground and getting a way poorer yield. So we just think that's a wise thing to do. And we'll be doing that as soon as we get biochar available to us.
So that value increase, you think is it primarily yield driven, or have you looked at reduction in inputs? I'm sure that's something you'll want to look at when you can do a larger trial. But the idea is that additional nutrient additions to a biochar enhanced soil should go farther and longer than it otherwise would in an unconditioned soil. Is that where that value is coming from?
That's where part of it is. We think the number one value is the increased yield. But your point is well taken, that as we know, charcoal will tie up nutrients, and so, but still make them available to the plant. So we should have less problems with our phosphorus and our nitrogen going down the river at application time. It would hold it in the soil longer, and will also hold a bit more moisture in the soil. That's not a big deal, but it's just another little icing on the cake that you get from the use of biochar.
Yeah, so I would say, going back to your Guyana example, where you've got those sandy soils, the moisture management potential for that biochar plays a much bigger role in a soil like that versus what we have here in the Midwest.
Yes, and that's a minor part we emphasize, because when we're on sand and it rains today, we have to irrigate the day after tomorrow. And the char will give us another day. It's about what that does.
Yeah. And so we've kind of gone through and conditioned our soils and built them up in the Midwest using water management techniques like tiling and that sort of thing. What kind of role does biochar play in the management when we talk about the infrastructure we've already put into soils in the Midwest now?
Well, we think that the biochar is just another tool. That does not replace pattern tiling, which many people are doing today. And incidentally, we strongly believe in that. And the advantage of the biochar means you aren't going to have the leaching problem of some of the nutrients that you do otherwise. But even in a dry year, there are periods when there's excess moisture. And what that really means is those plants don't get oxygen. It's not the water that hurts them, it's the oxygen, lack of oxygen. And so the combination of doing everything properly, including adding the biochar, is what makes it all work together.
So it's truly a systems approach of getting a soil to work together with a biochar and matching their properties to get an overall system that pulls together in the same direction. So in your experience, I mean, there's a lot of different kinds of biochars out there. There's a lot of different kinds of soils. What kind of work needs to be done in order to figure out how to pair those best together?
Well, we think it's fairly easy. That obviously some of the very best soils that are high in organic matter, very frankly, will have very little benefit. So you want to take the soils that are low in organic matter and have a high potential. And that's where the greatest value would be. In determining exactly how much biochar you need to put on, we don't know, obviously. And so some studies to evaluate exactly how much on exactly which type of soil would be highly advantageous for we farmers to know.
So now we've got a pretty good idea of what biochar is and what it can do for soils and its value proposition to farmers and producers. Let's talk a little bit about what you're doing in Redfield. This hobby plant that you have down there, what is it? What are you processing and what are your goals for that plant?
Well, in conjunction with Robert Brown at Iowa State University, incidentally, we met him a number of years ago and we're very impressed with his expertise in this area. So we've agreed to make a little pilot plant, which is an upgrade from the desktop type thing, but still smaller than a commercial plant would probably be. So it's designed to produce, to use about 50 ton a day. And I think, and you can correct me on this, but I think ballpark wise, we're going to get about 30% biochar out of that biomass, about 30% bio oil, and maybe about 10% of water and 10% that gets burned and goes away. So ballpark wise, that's what we expect to do with that particular facility.
And primarily you're set up to process corn stover as your feedstock. Is that correct?
That is correct. Technically, wood is probably the best product to use, but right here in the Midwest, we have an abundance of corn stalks relative to wood. So here at this location, that's primarily what we'll be using.
And what does that process look like? How do we need to go back in and gather that corn stover? How much do we need to put up? What kind of properties are we looking for it to have? And how much can we really take off and still maintain the soil properties that we need for next year's crop?
Well, on a good corn crop, again, ballpark wise, there's about 5 tons of biomass on the surface. There's a significant amount also below the surface. But of that surface biomass, we don't think you should take off more than half at the most. And so you should take off a couple tons per acre. And that can simply be baled when it's dry. And be very careful not to incorporate dirt in that. Dirt is not good for pyrolysis equipment. And then we have facilities to store this biomass under roof to keep it dry. And using that practice, I think you can maintain both the normal organic matter in your fields and also be able to add biochar to those areas that need it.
Yeah, the sustainable harvesting picture is one that gets a lot of discussion. When you talk to farmers in the area, they're very worried about maintaining their erosion control. But at the same time, what we're seeing is the new hybrids that are coming out of the seed industry are very robust. And we're growing a lot of biomass out there in the fields along with the grain. Do you see trouble with next year's crop if you don't do something to start taking away some of that biomass for impacts on yields?
No, but again, it's a whole systems approach. So you're removing actually some P and K with that biomass. So you have to replace that in addition to your normal P and K that you're going to apply. But as long as you do that, and actually there's some data to show, depending on what crop you're going to grow next, that there's actually some advantage with removing some of the corn biomass. But the whole key is to be logical and reasonable about it and not try to make bare ground, because that's not good for anyone.
Yep, that makes a lot of sense. So moving on to the other product that you're making out of this plant, you mentioned there's an oil that comes out as well. What are your plans for the oil component coming out of the demo plant?
Well, I can tell you it's not good to try to blend it with gasoline and put in your car.
So it's not a straight replacement for gasoline.
So I did that once, and after a while, only a very small percentage. And after a while, the car didn't run all that smoothly. But at any rate, there's potential various uses for the oil. And we've got 2 or 3 different entities that are inquiring and already want to buy our oil as soon as we have it available. And in addition to that, it's also potentially possible to put it through a procedure so that you can make fuels out of it to use in regular equipment. But also airplanes, believe it or not, you would think a jet airplane would want really good quality fuel, but they actually use very poor quality fuel. And so being able to blend it into airline fuel is also a possibility.
That sounds very promising. So you've got a home for all of these outputs coming out from the plant. something that the larger scale you've been able to deploy this technology at enables a lot of different testing that can happen. So it's really sounds like you're opening up the bottlenecks in the industry and kind of establishing product streams that can be tested in a wide range of industries. Another topic that really has been getting a lot of buzz lately is around the emerging carbon markets in the U.S. So much, in fact, that your fellow billionaire Elon Musk formulated the Carbon X Prize, your hobby plant of which is the subject of a award-winning application from the first stage of that X Prize. We can guess at Elon's motivations, but ultimately the goal of the prize is to spur innovation in the carbon sequestration sector. What do you see in the future with regards to emerging carbon markets? How does that impact agricultural practices in the Midwest, and does that change your view about what is happening in Redfield?
Well, this is interesting because partway through this project, when oil became very cheap, I told Robert Brown there was no way this would be economically viable, but we would continue it just because for research purposes, it's good to learn about what we can or can't do. But as you well know, the combination of the value of the biochar being more than we anticipated, the value of the oil being more than we anticipated, and now with carbon credit value, you put those three things together, and this should be very economically viable for anyone wanting to do this sort of a facility.
So that goes to the another question is, if 50 tons per day is a good demonstration size plant, what does a commercial plant look like?
Again, we aren't certain, but we think somewhere in the range of 5 to 10 times larger. If you get even larger than that, it might be the economically viable for the plant, but it's not economically viable to try to pull in the biomass from a greater distance that it would take to do that.
Yeah, so the collection radius of your feedstock is a big driving factor in the overall economics surrounding the plant.
Correct, that's our position.
Oh, yeah. And then what about the biochar going back the other direction? If we're going to return that to soils that are nearby, or does it look like there's enough value proposition that biochar could make its way out of the Midwest or down south into other soils? What do you see the distance limitation on biochar coming out of a plant like this?
Well, the economics of bringing in biomass versus the economics of taking biochar out are totally different. So you can indeed take the biochar for a much greater distance than you can bring in the biomass.
Very good. So we've got a few questions coming in from the audience. I'll try to work in some of these. There's a question about different types of wood and qualities of biochar. Do you have any experience with quality differences of biochar coming from different feedstocks?
I personally don't. But again, the university would tell you that wood is the best source. And so our people in California that have the fire problems and excess wood and what have you, that will probably be their seed stock there. And we may use a bit here because some people actually have trouble getting rid of wood chips from some of the problem areas where they've had wind and what have you.
Mm-hmm.
But in terms of large volume, consistent quantity, even though it's not the very best, corn stalks is a very suitable and satisfactory source.
And I'm sure that we've got a bit of expertise on how to deal with corn stalks. So starting out in an area that's within your wheelhouse and the wheelhouse of Steinseed makes a lot of sense.
Yes, it's actually, we originally were doing some round bales, and we've shifted everything to square bales. They're easier to handle, easier to store. And so our machines today to grind those are primarily designed to grind the square bales.
Excellent. There's a question here about wondering about cover crops. As we've seen some newer research come out regarding cover crops and working those into the cropping cycle to help with some of these carbon issues, to help with some of the erosion issues. Have you done much work with cover cropping in conjunction to the corn production? Is there a viable path there to recover some of those cover crops and use those as additional feedstocks to feed a pyrolyzer?
Well, historically, we'd use rye as a cover crop. And we think if you think you're taking off too much biomass, you absolutely have to put something back on. And rye would be a potential to do that. We're in a little bit of a unique situation. We have quite a bit of seed corn production. And so in seed corn production, you have small inbreds, you've cut out the male rows, you've cut the tops off of these small inbreds. So the amount of biomass you have is frankly very poor, not adequate enough to cover the ground. But we also have, and incidentally, you harvest seed corn very early in the year. So that biomass breaks down. We almost always start seed corn harvest at the end of August. And so by now we're almost well complete on harvesting seed corn. So what we do in our case is we take discarded seed corn and put back on this soil and raise a corn crop in the fall. And the advantage is our cost is obviously zero because we have to get rid of this discarded corn anyway. And it grows right away in these warm conditions that we have now. And yet the frost will kill it over the winter. So you don't have to do anything to destroy it the next year. And you've got a nice cover of biomass material over the ground. So that works very well for this specific situation.
Sure.
In other situations, you need to use other alternatives.
So what does that picture look like come the next year with that crop on the ground? Is that anything you have to deal with, or can you you plant right back into it? What does that look like?
No, you don't have to do anything any different than you would normally do. If you're strictly a no-till, you can plant right into that. If you want to do tillage, actually, the nature of that growth is such that you can run your field cultivator right through it. So either way will work fine.
Very good. We've got a question back about the plant. What have you seen are the challenges to scaling up to commercial size production from both the biochar side of things and from the oil?
Well, anytime you scale up anything involving heat, it may or may not work exactly as you think it will. So we've got some little bugs to work out of this facility, as is to be expected. But we think over the next couple of weeks, we hopefully will have this operating.
Sounds very promising. I had a question come in about the water production from the pyrolysis plant. Is it considered wastewater or is it clean? I can answer that for you. The way we operate the plant, we actually do not cool and condense any wastewater. We send the lighter cuts of oil to a thermal oxidizer where they're burned for emissions control, and we recycle that process heat back into the system. We've got enough left over. We do a heat exchange in order to preheat the fluidizing air for the fluidized bed, but we think there's enough process heat left over there that if we need to go back and dry the incoming biomass, we have that option available to us as well. Harry, you described biochar applications to soil represents carbon dioxide removal from the atmosphere. How does this compare to the much talked about direct air capture systems that use large fans and sorbents to produce concentrated CO2 from the air?
Well, it's my observation that when we have the corn plants growing out there, that's a pretty cost-effective way to do this. Incidentally, I want to back up on your question about the water. For many years, we had our winter nursery in Florida, and the inspectors came out to want to see what we were doing with that water when we dried our seed corn. And so it's a little bit about some of the water that's in the biomass that evaporates here. So we pointed out to them that it evaporated into the air, and they didn't know quite how to handle that.
Yeah, and certainly if you're running a drying operation in front of that, driving off the moisture that's in the feedstock as it comes in from the fields, you mentioned you have the benefit of having under roof storage. Man, that really makes a difference in being able to have a dry bale coming into the plant if it's been able to sit under roof storage and naturally dry. What kind of moisture content do you see in your feedstock bales after they've been able to sit and self-dry for a season?
Well, we like to see them below 10%, but we would actually like to see biomass going into the plant under 5%. And we think once we get operating, there will be some excess heat we can pull off and then actually take the excess heat, which is free, and dry ahead of time so that we can get that biomass down to under 5%.
Yeah, it makes a lot more sense using free or low cost heat than it would be in using a heat from a pyrolysis environment, which is very expensive heat, being much higher temperature. So that approach makes a lot of sense. You have any developments to speak of for mixing biochar with other products or treatments to make it better for a direct soil application compared to raw biochar? I remember a few years back, we did a soil trial with biochar where we brought in a truckload of the material to begin to incorporate it into a soil. And as soon as the dump truck dumped it off of the truck bed, it ended up in the next county. So we did probably a pretty good job of applying biochar to the next county, but it didn't go where we wanted it to go. How are you addressing that issue when it comes to biochar application to a field?
That's a good point, because we also brought in a load of biochar as an experiment a number of years ago. And my employees informed me that if we ever did that again, there would not be a single one of them working here. So the point is well taken, that this is very dusty, light material. And you can either pellet it, was one option, which we've tried that some. Or more importantly, maybe you can use equipment that's designed, as you well know, the kiln material is sometimes put on highways down ahead of time. So there is equipment designed to spread very light material over the ground. And if you do that on a reasonably calm day, that shouldn't be any problem at all. And remember, we're going to incorporate that into the soil right away, immediately.
Mm-hmm, mm-hmm. Yeah, has there been any other work to increase the nutrient value of pyrolysis char? Just as a note, most of the nutrients that are coming in from the feedstock are going to be sequestered in that char material in addition to the carbon. Have you thought about formulating kind of custom fertilizer mixtures using biochar as a base?
We haven't worked on that, but there's talk of doing that. And obviously you can either take regular commercial fertilizer or a regular manure that's available in a way of getting it mixed in. So either one of those would potentially enhance the value of the application of the material.
We talked a little bit about energy around the plant, at least in terms of moisture content of the incoming feedstock and the important role that plays in the pyrolysis process. What is the energy source for the pyrolysis reaction in your demo plant?
This is a very good point, because in all fairness to Robert Brown, when we first started this a number of years ago, it was assumed that we would want to do this in the total absence of air. And today, what we're doing is allowing a small amount of air in, so that actually a primary source of the heat is actually burning a small portion of the biomass. And that puts the heat right where it's needed to be in this fluidized bed that we use in this process. So that's been a very effective and more cost effective. You do have to use natural gas as the initial startup to get your sand warmed up for the fluidized bed. But once you get that started and going, a substantial part of that heat actually comes from the biomass.
So at least the reaction portion of the process is energy neutral. Is that what you're describing?
Yes, it uses a teensy bit, and then obviously we use some electrical motors and what have you, but it's relatively green, yes.
Very good. And removing that heat transfer bottleneck by doing a direct exchange into the system really, I would think, simplify the process quite a bit. You don't have to have, say, a full-time external energy source burning, say, natural gas and transferring that material or that heat load into the pyrolyzer itself. That must simplify the equipment somewhat.
Yes, well, the fact that the biomass is right there mixed in with the sand granules and burning, so that's immediate effective heat transfer, much more efficient than I would have thought of. So we want to give Robert Brown and the staff there at the university credit for that.
Very good. Sounds like you've got a pretty good partnership formed with Iowa State. What do you see that partnership looking like going forward?
Well, this is not our area of expertise, is we think is the seed area. So this is something we're sort of doing on the side, but we're happy to cooperate with the university on this. And potentially we may put up a larger plant in addition, but this area is not the area that we're going to put most of our emphasis on.
Very good, very good. So this you described this plant basically as a large pilot. Do you anticipate adding any other unit operations to this plant, or are we sticking to the core units, or what do you think the future of this demonstration plant is once the core technology has been proved out?
Well, our idea is to let it go like it is, but Robert Brown and his staff, they're always saying, well, we could do this and we could do that. So they may convince me of that once we get this going.
Very good. Open to development, at least. That's an excellent interview, Harry. I really appreciate you taking the time to join us. I think it's been a very enlightening experience and an absolute pleasure. I'm looking forward to seeing both literally tons of char and gallons of oil flowing up from that old brick factory in Redfield. So I wish you the best of luck on startup. And again, thanks for taking the time for joining us today.
Well, we enjoyed the visit and thank you much.